transfer learning is definitely a huge boost to this whole area, to the level that today when people talk about deep neural networks, 80% of the time, or even 90% of the time, people do not want to develop entirely end-to-end custom models, but they say that, can we reuse one of these large networks? It could be AlexNet, VGD, GoogleNet, RESTnet, MobileNet, DenseNet. There are lots of efficient net. These are all different large network architectures which have been proposed in the history since the first time AlexNet proved to be a challengeable and commendable architecture for improving the accuracy of ImageNet from 70s to 80s by quantum jump in terms of percentage accuracy. Since then, lots of effort is going on in creating reusable transfer learning architectures. And so common people who are developing their own custom models do not always go and develop custom models. Instead, they can resort to transfer learning as a basic idea. So if you see the basic architecture, which was the first of the kind, such large architecture, which was responsible for the revolution in the history of image processing, and also you can say the start of this revolution of deep learning, is this architecture called AlexNet, where Hinton, Sutskever, Tversky, they developed this architecture and proved the ILV-SRC challenge by incrementing the accuracy levels by 14+% over the previous 70% levels accuracies. And this caused a major havoc in the community, and saying that, oh, what is this new beast called CNN? What is this new beast called AlexNet? What is this new beast called deep learning? And then onwards, it's no holds barred. We've seen since 2012 to now, in just 8 years of the history of transfer learning, we've seen huge jumps and bounds of efficient networks being evolved, and they contributing to amazing possibilities in context of text, audio, and image processing. So this was the first of the kind architecture which was proposed by Hinton et al. In NIPS 2012. So basically, this had most of the features the same like what you'd see in a CNN. You would see what you will see in a CNN. You'll have a convolution, you'll have a feature map output of that, and you'll have ReLU. Then you'll have max pooling. Then you will have a dense layer at the end. So it is concept which is similar. Only thing is, instead of having just one set of such convolution plus ReLU plus max pooling combination, which is the whole set, we have many such combinations woven together. So you see here the AlexNet, the way it works is basically having a collection of convolution, then max pool, then convolution, then again max pool, then again convolution, then again convolution, then again convolution, then again max pool. So it's a collection of different operators operating one after another in a something like 12 to 13 different layers of architecture for your particular final image classification task. So you can think of it like the basic CNN architecture does not change. It still uses the same three basic operations: the basic convolution, which is basically a downsampling, then the feature map being subjected to ReLU, then the max pooling. It is these three which are the foundational. Then at the last, we have the fully connected dense layer, which is basically responsible for the final classification for your target domain. So that architecture remains same. Only thing is, in between, you have multiple combinations of the convolutions and fully connected networks. So most of the architectures actually go in, basically differ in how many different layers, different number of times this convolution, max pooling combinations are repeated, and each time what is the type of filter. It is these kind of changes which makes the change in the corresponding architecture. So this is the overall AlexNet architecture. you see it's basically multiple convolutions in one sequence, then max pooling, then convolutions, ultimately resulting in a dense layer for the final classification. Then the next basic architecture which has been very, very popular is a slightly deeper architecture than AlexNet in terms of number of layers. It is called VGG, very deep convolutional networks for large scale image recognition. And this is basically in 2014, this was the runner up. This has, if you look at it, it has around 140 million parameters, given the number of layers and given the number of convolutions, etc. And VGG actually has been transformed into multiple variants, because some of them constrain it to 16 layers, some of them constrain it to 32 layers, depending upon what is convenient for you, depending upon the level of variance, and depending upon the level of types of classes of images you have for your domain. You will see that you will use either VGG 16 or VGG 32. So this is a classic example of typically what you do in VGGNet. You start with 3x3 conv, again 3x3 conv, then max pooling, again 2 convolution, then again pool, then again conv, then again pool, then like that, and finally you have the 3 dense layers, finally the softmax layer for the classification. So this was basically, you can think about as a variant which led to between 16 to 19 layers. Well, later, of course, 32 layer version was also invented. And in terms of in ILV SRC 14, it was second in place with 7.3% top 5 error. 7.35% error means you're talking about 92.7% accuracy. Imagine before 2012, we were talking about accuracies in 70, 74%, and now in just 2 years with the use of AlexNet and variants of AlexNet, where you moved from AlexNet, which was just 8 layers, to VGGNet, which was 16 to 19 layers, you moved from 74% to something like 92.7%. Imagine the jump in accuracy level. So from now on, it's just going about more and more architectures which are adding more and more layers and getting closer and closer to 99% or 100% accuracy in the ILV SVRC challenge. So VGG 16 is basically the one which has 16 layers. And as you can see, it has multiple 64, 128-bit convolutions, 256 convolutions, 512-bit convolutions, and intermittent max pooling layers. So as you can see, the basic innovation in CNN was the concept of convolution, max pooling, and ReLU. But beyond that, it's been mostly architecture play. All the people in the deep learning field, it's not that they have done fundamental contribution, but they have done practical contribution by evaluating complex architectures over these foundations in order to develop more and more practical examples of how you can get your practical problems to be solved in realistic time, rather than wasting time in always building custom multi-layer, custom neural network architectures. So VGG 16, as you can see here, is basically a set of 16-layer architecture. Continuing on, we see GoogleNet, which was the winner in 2014, beating the VGG model. It is significantly deeper than AlexNet, but it has much less parameters than AlexNet because it focused on computational efficiency. So the idea what they do is they try to look at perturbation in terms of what kind of filters can be used optimally, so that you don't have to always go into very high level of parameters to be discovered. So it is far more efficient, but at the same time, it uses much higher level of layers. Today, in fact, GoogleNet, this is the first version, but the GoogleNet we're working on today, which they're working on today, is a 500-layer model. And they are looking at capturing everything and anything in the universe with this kind of a model, which is 500 layer. You can imagine the kind of computational power that kind of a network will require. Then Microsoft has also put its stakes in the game by providing a series of networks around a basic architecture called ResNet. It's basically a highly deep network with something called a 152-layer network. And what this does is they actually offer a network to ease the training of very large deep networks as compared to those which are much shallow. So each of them have invented some ways of optimizing the overall performance by reducing parameters or reducing the training time, etc. But it's not that just these are the only networks which are present. You can look it up. There are concepts networks which are coming up in the recent past, like MobileNet,